So, like I said the other day, Java is a very widely used programming language, right? Lately, Python's been getting more hype. The nature of computer programming generally is it's becoming simplified. It's becoming easier for more people to work with. So, languages that used to be more popular, like assembly and C++, they still have their uses, but they're giving way to other ones that require basically less expertise on the parts of the users, right? Because you can crank out code faster in those, and that's often an important consideration. So Java, again, still widely used. Where it's widely used is applications running on servers. Simple reason for that, Java, because it's not tied to a particular hardware configuration, you can write one version of a Java program, test it, make sure it's running the way it's supposed to, and then put it on any server machine to run. And if you're some giant operation like like Facebook or Google that has like tens of thousands of servers, or Amazon, you definitely don't want to be in a situation where you have to make sure that every one of your servers is the same hardware in order for your code to run properly, right? Because those guys, they all have different generations of servers at different times. You don't want to, and some of them are always being phased out while new ones are being rolled in. You don't want to be in a situation with those organizations where if you're going to replace one server, you have to replace tens of thousands all basically on the same day. And so Java is a huge help in that environment, right? You write the program, and even though you might have hundreds of different hardware types in your servers, well, you still only need one program for it. Okay, that's an important thing. Other places where it's used, large-scale data analysis. If you've heard of Hadoop, right, or its successor Spark, then those are some possibilities. It's also, last I checked, the default programming language for Android apps, and it's in other places as well. So I'm not going to sell you too much more on it. If you're really, on the fence about it, you say, hey, should you learn Java programming in 2024? I'm sure you can find an article about that says, yeah, it's worth learning. Okay, so big features of Java. Number one, platform independent, means it can run on any kind of hardware. So we'll talk about how that works in a little bit. And number two, object-oriented. We'll talk more in detail about that. But for right now, basically it means any program you write in Java is going to be automatically include some modular features that basically, instead of writing one big slug of code that can all interact with each other with, unpredictable connections, instead you have very clear demarcations that one part of a program interacts with other parts in very specific and well-defined ways. So you limit the number of things that can go horribly, horribly wrong. Okay. And again, we'll talk more about that a little bit. Okay. So short version of Java's origin story was released about 30 years ago, and it was designed to support what was called embedded computing. So embedded computing, basically you mean the Internet of Things, right? Except this was before all those things were on the internet. So embedded computing basically means things that are computers, but you don't think of as computers. So like smart components in your car, for example, okay? The issue with why you needed something like Java for that, imagine if you're talking about what's something smart you could have in your car. Suppose a temperature controller, right? Could be a kind of computer that automatically senses what temperature you want your car to be and, deals with whatever to maintain that. Now, it stands to reason that over time, there are going to be many different manufacturers of many different models of that particular hardware component, right? You wouldn't expect there to be just one. Just like, iPhones start out being iPhones, but then everybody makes clones of them, same kind of thing. So because there are going to be many, many different hardware models, it would be a nightmare to do this kind of code for them in a language that required exact knowledge of that hardware, right? Then you'd have to potentially design specific code for every particular manufacturer model variant of that component. And you'd have to write different kinds of code for every product that would be out there, right? So there's temperature controllers, there could be anything else that you might have as embedded computing. So Java said, you know what, we're going to write this kind of code where you can write the program once, it'll automatically be translated to run properly on whatever the hardware is. And that's how we're going to get around this problem of not having to write specific source code for any particular kind of hardware. And there was a big boom in the early days of the internet as well. Same kind of thing. You had a lot of different devices that could connect to the internet. And if you wanted to have a little program on a web page that would work the same for anybody, they did those in Java too. They were called applets, although they've been gone for about 15 years. Okay. Nowadays, part of why there's still so much Java out there, part of it is organizational inertia, right? That basically organizations have these massive systems with the code all written in Java. And unless you have a really good reason, you don't want to scrap that and start again from ground zero with some other language, right? It's easier to build onto what's others there. The other thing, Java's been around for a long time, so the code libraries, they're pretty extensive. It's pretty easy to find, highly skilled Java programmers. So those are some selling points. It's not like it's some new cutting edge language there. It's really hard to find people who are knowledgeable about it. Java's not like that, right? Java's been around forever. Most professional programmers are at least familiar with Java. The downside is that because Java is, one batch of code that's widely used, if there are security threats, right? If there's exploits, they can damage a large portion of a system. So because of that, the bad guys are always sniffing around to find vulnerabilities in Java. So there's some good, there's some bad, but the reality is Java is definitely out there, and it serves an important need of basically being able to write source code once and having it run on any number of different hardware models. Okay. We can skip all this. The short version of all these next few slides is, in the early days of computing, hardware was really expensive, so the cost of writing software was relatively cheap. And number two, there weren't that many different computers out there anyway, so it didn't make sense to go to a lot of trouble designing a new language that was going to be, the same for all of them. You actually had to physically go in and flip switches on machines. Nowadays, right, there's tens of thousands of different hardware models for anything you might want to think of. And the idea of writing specific code for them, for each hardware model, is really a problem. Even, well, I could talk more about it, but just push the I believe button and let's let that go. So the basic principle of Java is what's called WORA, which stands for write once, run anywhere. And the idea, again, what I've said, the source code of a program can run on any machine with proper translation. And Java's not the only not the only language that does this. There are other languages that piggyback on the translation models that Java uses. And it is theoretically possible for any program that has this abstracted intermediate layer. So let me talk about what I mean. That's what I was going to get to. Okay. So suppose you're talking about, we got to size this up. 20 ought to be good. C++, right? Code for particular hardware and memory configuration. Okay. So if you write a program in C++, you have the ability to target particular memory addresses, and you can reserve a block of memory where you want some particular data to be stored. Likewise, you might have a graphics card on your machine. You need some mechanism to find out what the memory addresses on that graphics card are so you can draw appropriate graphics to appear correctly on the screen. Okay? So in C++, you have your code and you have a graphics card. All right, so the code, number one, must discover the graphics card memory addresses, and then must deliver the proper updates to those memory addresses to draw the graphics. Okay, so that's what the code does. Whatever it's going to do, it sends that to the graphics card, and we're going to say graphics display updated. Okay, with Java, it's different. With Java, code for any hardware, no direct control over memory addresses, right? So and this was a bit of a headache for me because I learned Java from a C++ background. And so, you know, when I was first learning it, and the documentation online was not as thorough as it used to be. It wasn't as thorough then as it is now. I spent a lot of time trying to figure out ways to, you know, access particular memory locations. I say, I want to reserve a block of memory to do this. And, you know, eventually I found, yeah, not only is they're not a function for that, it's just not part of the Java language. You're like deliberately, completely blocked from doing that. So instead, what you have is this translation layer, right? So at installation, Java maps out your hardware configuration to specific points in Java, right? So when your source code says draw a line from 0.00 to, I don't know, 99.99, Java already knows the graphics card memory addresses and how the source code should be converted to machine language. Okay, because everything ultimately has to run as machine language, you know, which is just like a string of numbers being fed into your CPU. We see it as words, but we go through a compilation process. We compile the code, compile the source code, so it can actually run on the machine, right? So Java basically says, whatever you're doing in your source code, it's going to somehow be translated to your particular hardware configuration. Okay, that's the difference. Now, having said that, you guys may have heard of Windows DirectX. If I say DirectX, do you know what I'm talking about? What's DirectX? You could say that. It's basically the same translation, right? So one of the problems you started to see in the mid-90s was this proliferation of a wide variety of graphics card models. And so if you bought a video game in the mid-90s, one of the things that would typically make you do is walk through a bunch of steps. It would say, hey, I'm going to display a bunch of bars, horizontal bars. Do they appear correctly? Is the sequence red, green, blue, or is it, you know, yellow, pink, gray? And then it'd do the same thing with a set of vertical bars. And basically through these kind of tests, it would try to determine what kind of graphics card you had, right? But as there become more and more graphics cards with more and more different, you know, amounts of memory, that whole process became too complex. Humans didn't want to go through that manual thing for every game. So Windows came up with this idea, something called DirectX. And DirectX is basically a translation layer, again, between the application source code and specifically everything involved with producing the graphics on your machine, right? It's the same kind of it's like what Java does, but it's not for the whole machine. It's just for the graphics. Okay, so that's the second point here where I say WARA is theoretically possible for any programming language that includes an intermediate layer for abstracting hardware. Basically, if you provide that translation from the things you're trying to access with your source code, yeah, you could do it. And DirectX works with C++, for example. So anyway, the other caveat is that even though you can write Java code that in principle will run anywhere, there's no guarantee that it's going to run well somewhere, right? So for example, if you have a you know, an application that works really well for a mouse, well, maybe your touchscreen device doesn't really have anything much like a mouse, right? They might have different display sizes. So your application might be written with a fixed size pixel count that isn't going to display well for whatever reason on a big monitor or a small monitor. And of course, memory availability. So the source code can run, but that doesn't necessarily mean it's going to run well. Just run well on comparable machines. Okay. Now, having said that, because Java applications, the biggest place where they're used is server side, well, graphics don't really matter, right? Stuff is running on a server. The end user isn't gonna, you know, see any of that, and the organization isn't. Yeah.
So would you say Java is basically like backend development?
Absolutely. I mean, you can write applications that aren't backend. For example, I can't remember if I mentioned it. We got this. Yeah, but you don't want to, mostly you don't want to use Java for any kind of user interface type stuff because it's always going to look crappy. It's going to look like lowest common denominator graphics. I'm going to bring this thing up. So this is a thing I've done for IDS 200. It's still in progress, but basically I can generate random batches of data. Okay, so I'm going to run this just to give you an idea of what a GUI looks like. There's something going on here. What's the issue? All right, there we go. So I can bring up something like this. This is my Excel instructions. And if I want to create a bunch of names, I can give it a name like, I don't know, item number. And I can create another one and have the second one be quantity. And I can use drop-down menus to give, this one will be an integer with, it can be random. So with a base of 1,000 and then a random number of up to another 1,000. And then the quantity I can do again, integer total. Let's do base of 5 with a random 6 and then a 0. I should just do 1 here because you're always buying at least 1 with, again, I don't know, random of 10. Okay, and then I can base rows, how many? 12, random rows, another 5. Okay, so let's see if I, boom. Okay, and at this point, I can generate a bunch of data. It doesn't go into Excel format yet, but you could cut and paste this into an Excel thing. Okay, and again, like I said, the key takeaway, the graphics are pretty basic, right? You can do more than this, but it's never going to look as good as what you're going to do with C++. Okay. Or more correctly, you can make Java graphics look good on one particular machine, but it's not going to translate as well to other machines as C++ graphics will. All right. Okay. Cool. So again, Java is important to the early internet. Again, there was a lot more manual work to coding back in the 90s, right? Nowadays, the IDEs are better. They're more helpful. They correct a lot of problems. Plus, there's a lot of standard code libraries, so people don't always need to reinvent the wheel. So the fact that you could write this code once, debug it, get it working, get it up and running fast, that was really important for early internet, anything you were doing as far as, programs running on servers in particular. You also had applets for programs that were embedded in web pages. There were little Java programs. You designate some horizontal, some rectangular box on your web page where the application would run. It used to be a big thing about 20 years ago, but they've been pretty much entirely replaced by scripting at this point. All right, the last one I saw in the wild was almost 15 years ago. So long time. Okay. Other stuff, I don't know. I guess you could say I covered a lot of this the other day. If you guys read this and you're like, hey, I have some questions, and I'm happy to talk, but I kind of want to get to some other things today. So, okay. Big things in Java. These are the things we talked about the other day. So the Java virtual machine, that's that translator. So what happens is when a program launches in Java, Java builds this Java virtual machine from the hardware mapping. Okay, okay. When a Java application is launched, the Java software, well, I'm not even going to say that. A JVM, Java virtual machine, is created based on your machine's hardware mapping to Java. Okay, so wherever it thinks things like your ordinary memory is, your graphics card, all like that, Java is going to build this Java virtual machine that is like a sandbox for running applications, right? Basically, a reserved space of memory for your program. Also includes what's the word? Space of memory. Oh, also includes application threading, right? So you have one main thread of your application and it can split off into other ones, right? So you can have multiple things running more or less in parallel at the same time. Okay, so that's what the Java virtual machine is. Now, in order to have a Java virtual machine, you must have a JRE, a Java runtime environment. All right, basically all the things you need to make runnable Java programs. Okay, that's what the Java runtime environment is. It's going to regulate that whole creation of the Java virtual machines. And in order to have the JRE, you need, of course, a JDK, a Java development kit, right? Which contains the necessary goods to create Java programs and process the code and, map the hardware to Java, etc. Okay, so the first thing you need to do, that's why you had to download that JDK. The JDK contains everything you need to do, right? Once you unpack and have that, you'll have the Java runtime environment. You'll be able to have Java virtual machines to do whatever you need to do at any particular time for any application you're running. Okay, so that's it. Anyway, questions on that? The rest of this is a little bit about object-oriented programming. So any part of that doesn't make sense? Anything you'd like to talk about a little bit? Does it make sense? I hope it does. Okay, well, all right. So next thing, object-oriented programming, right? So I'm just going to give an example about how modularity is important. Okay, so suppose you write a banking application and the user accounts are objects. Okay, so what that means, remember, objects in object-oriented programming are basically standardized chunks of code that define, number one, the data stored for a particular thing, and number two, the actions a particular thing can do. Okay, so what sort of data would you expect to be stored in a bank account object? What might you reasonably expect to find there? Suppose you have a bank account, right, in some kind of online banking application. What sort of data would you be expecting to store in that? Sure.
It's like your savings account, checking account.
Yeah, whatever. So what kind of data would those hold? Suppose it's a checking account. What kind of data would you expect to hold in your checking account? What's that? Okay. Transaction history. Okay. So we'll say here, I'll just put that here. Like transaction history. Okay, sure, that could be a thing. What else? How do we know it's your bank account? Sure, account number. What else? Address. Possibly. Well, statements would be transaction history, but sure, I'll throw in statements, however you want to format that. Name. Excellent. One more really obvious thing on a checking account. Yeah, your balance, right? How much money is in there? Okay. These are all reasonable things you would expect to, right? You'd expect to see that stuff. Maybe a password, email, right? You could think of other things but these are all perfectly reasonable, sensible things to have in a bank account object, right? Okay. What sort of actions would you reasonably expect your bank account object to be able to do? Transfer money. Okay. So we'll say send money. And if you're going to send, you might as well receive money, right? Sure. What else? Suppose you want to just check out the state of your account, right? You might go in and check balance. What's that? Well, pay bills, but that's arguably send money, but I'll go with pay bills. Maybe there's a distinction. Sure. What else? What's that? Okay, sure. Lock the account. Sure. I'll accept that. Okay, poll history. Sure. Okay. So things like that, right? Now, the point of objects, two things. Number one, when you create what's called the class for this bank account object, the class definition will include every data the object can hold and every action the object can perform. If it's not in the class definition, it can't happen. Okay, so this is really an important thing for restricting the number of things that can go wrong, right? Basically, if you say, hey, the only things I can do with this object are send money, receive money, check balance, this, other parts of the application have to call those specific what are called methods, and that's the only thing they can do. You can lock out any direct access. So let me give an example of what I mean, because this is what we really get into at the end of it. And this is something that is really, it's hard to impart the importance of this in a classroom setting, right? Because when you're coding stuff, you all have complete access to whatever you're doing, you're writing stuff. It's hard to get that feel of writing code for a large organization. I'm going to try right now. Okay. Suppose you have a bank account object, and it has as data a balance. Okay. And that balance, as it happens, is wide open to anything else in any application, right? So what you could have, some other application can just call the instruction for object X, update the balance to some arbitrary value Y. Okay? You wouldn't want another application to be able to do that. You wouldn't want an application to just go in there and say, hey, I'm just going to directly change this balance. You might say, well, why is that going to be bad? The balance is going to be changed sometimes. Well, the point is, if there's some flaw in this part of the code, right? Some programmer types in the wrong number, or, some user says, oh, I want to add such and such amount. It's a lot easier for there to be a vulnerability if you allow that sort of open access to that particular chunk of data. So that is actually a massive, massive cause of horrible problems. So instead, what you can do is you can implement privacy. You can say, hey, this data, I'm going to make this private, and it can only be direct. It can only be updated through some method. Like I'm going to call this one called credit and another one called debit. Okay. And you might have it set up in your application that the only way you can change this data value is either by going through this credit method or going through this debit method. And the credit method can include checks. So it can include validation. And the debit method can include validation, right? So when some number comes in and the credit validation says, hey, I'm going to try to just inject like $2 million or $2 billion into your bank account, that may be something that's not really feasible. That may be something that, requires you to physically go to a bank and hand a shoebox full of 50s to a bank teller in order to make that happen, right? You don't want to just have that easily happen online because somebody could be faking things. Likewise, if a debit is happening, you want some kind of validation check in there. You want to know that the user has agreed that this money is going out, that the amounts are proper. You don't want to just let any other application that might in fact be hacked be able to go in there and say, oh yeah, I can just directly access the balance and pull money and send it somewhere. Okay. So when I say modularity is built in with the objects, we'll see how this works over the course of the semester, but basically Java inherently includes that kind of modularity. And if you say, like we do here, the only ways you can change the balance That means instead of having to check every application, even if we're assuming there's no hacking, there's no malfeasance, nothing bad, we still have to say, hey, any outside application that changes that balance, we have to be super careful about that. And any change that happens in that outside application might somehow change that code. And we need to go over all these changes with a really fine-tooth comb to make sure we're not wrecking our banking operation. If instead you say, hey, the credit part is going to work like this, the debit part is going to work like that, we just say, as long as the inputs are correct, we've limited the number of things that can go wrong, right? We just say, hey, as long as this thing, regardless of what the source is, if it sends a validated instruction, we can accept it. Okay. So for example, suppose in your bank, you've gone from a shift. Once upon a time, you just had bank tellers. And then in the 80s, you brought in ATMs and you're pretty excited to have them. And, eventually, credit cards, all the rest, debit cards. And at some point, you decide to go online, right? And you have a variety of online portals that users can use. Well, if you don't have this kind of, modularization in place, you have to do a whole lot of work on the code, making sure that every other application is, working in a safe way in every case so that you don't wreck somebody's balance. But if you say this is going to be modular, I just need to process the credit correctly, you can just say, hey, as long as the amount of the credit is correct, then I can process that. It doesn't matter what the source is going to be. As long as some other application sends a valid credit instruction to the account, we're going to treat that as correct. And likewise, as long as any debit operation sends a valid instruction, right? Whether you're pulling money from an ATM or paying a bill online, as long as that's validated somewhere for your account, we know that there's far fewer things that can go wrong because the validation step is inherent to it. Yeah.
So does Java interact with SQL? It's like kinds of like, I guess, like these changes, say for example, or do you create like, I guess, the trigger, say for example, for
Yeah. So what would happen, right, is you basically have it doesn't have to be Java, but for purposes of the discussion, let's say it is. Java performs the actual changes to the database, okay? And SQL is like those kind of inputs from an outside application, right? So SQL code just sends an instruction string to Java. Just like if you're looking for a particular file, you type in the name of the file and it comes up. Same thing, the SQL code gets fed to Java. Java processes it into actual instructions that get sent to the database. Okay, SQL by itself really can't do anything. It's like typing in a file name. Yeah? Okay, cool. Yeah. So again, it's the same kind of idea, right? Imagine if you have a big database and SQL code might be arriving from any number of outside points, right? You don't necessarily want to allow anyone unrestricted access to the database. You want to say, hey, some records are off limits to you, right? Like if I'm looking at UIC payroll, I can look at my own payroll situation because that's important, but I can't look at anybody else's. But if I'm a payroll employee here, I might need the ability to at least look at parts of anybody's payroll status, right? So I can answer questions. Okay, so that kind of modularity is built into Java, right? There's ways to get around it and there's ways to code badly, but the default setting on Java is you're going to code in modular chunks like that because it's more of a headache up front. It's harder to code that way. But long run, when you have an application, it's safer, it works better, fewer things are going to go horribly wrong. Okay. And that's pretty much what all the rest of this stuff is about, right? So again, there's a couple more slides, but modularity example about bank account object, this is the same thing, okay? Now, the structures, basic structures, we'll talk about all these today. We'll do a little bit of practice coding. So I'm going to put these all in paint, okay? Basic coding structures in Java, right? So the first thing you're going to create is the project. And the project is basically a file folder plus Java versioning information, right? So whether you're using JDK 8 or 16, whatever JRE you're using, things like that. Okay, so that's what the project is. It is a file folder. What goes in that? Well, project can contain one or more packages. All right, packages are file folders for holding Java classes. Okay, and so what are classes? Classes are the instructions for making objects. Think of them as recipes or cookie cutters, right? The class contains the list of data stored by any object of that class, as well as the list of actions that any object of that class can perform. Okay, so data and objects. And while the program is running, it may be necessary to create one or more objects of various classes. For example, bank account objects in an online banking application used by many customers at the same time. Okay, so if you say that we have a class for bank account, the class specifies, oh, a bank account object is going to hold this data, it's going to be able to do these things. Well, while the program is running, right, you have some server that might have tens of thousands of connected users, and so it might need tens of thousands of bank account objects, right? One for each connected user. Okay, that's the basic stuff. So we're going to make a project. We're going to just leave the package. We're going to use the default package for now. We're going to create some classes. We're going to create a program. Okay, sound good? All right, so if you don't have Eclipse up and running yet, please take a minute to get it up and running. If you don't have Eclipse, that's okay. All this is being recorded. You can come back and check it out. Okay, so while people are booting up Eclipse, I'm going to mention again what an IDE is. So IDE application like Eclipse, there are others. For what it's worth, I started out learning on NetBeans that maybe some people like, I don't know, but that's the one I initially learned with, and Eclipse was a big change for me. But it is one application, again, allows writing source code, debugging source code, and creating executable applications. So you can write source code anywhere, right? You could write it in Notepad, you could write it on a piece of paper, but how do you get it translated to machine language? Well, that's a problem, right? The other thing, debugging. Well, the IDE has some automated stuff that if your code is syntactically invalid, it'll say, whoa, that's messed up. You got to fix that, right? So it gives alerts. Now, back in the day, the debugging wasn't always that great. It's still not perfect. It's limited, but, you know, a lot of people, most mistakes tend to be simple. They tend to be like little punctuation mistakes. You forget a semicolon to close a line, or you forget a bracket to close something out. There's a lot of that. The debugger is decent at catching that stuff. Obviously, if you have some bad logic in your code, right, some algorithms that are faulty, yeah, the debugger isn't going to be any good for that. Okay, and then creating executables, converting your source code to machine language that can actually run. All right. So also, one nice thing about an IDE that's not inherent to it, it's just a good consequence, is that it provides standard code libraries, right? So if everybody's using the same version of the IDE with the same versions of the JRE and JDK and all that, then you know they're going to be able to use the same libraries, and code that you write on one version is going to be compatible with whatever code the guy in the next cubicle needs. Okay, so again, in an organizational setting, that's pretty important. All right, so the one we use, Oracle's Eclipse IDE, is very widely used by professionals. If you go out in the real world and you code in Java, you know, there's a pretty good chance that, you know, you'll be using Eclipse there as well. Okay, there are other ones, you know, and there are extensions to Eclipse, that's fine. But one of the big selling points for using Eclipse is, of course, that it is free. Yay for free. Okay, so let's do a little coding. Let's have some fun. Okay, so first thing I'm going to do, I'm going to make a new folder. New project folder. Let's do it. So to make a project folder, go to project. Don't do that. Do this plus thing. All right. So we do that drop down menu there, and we can just make a Java project. Okay. So we're going to be very creative and name the project folder Fall 2024, well, IDS 201. Sometimes I teach 401. Okay. And if you have it, if you have Java Standard Edition 1.8 from the JDK8, use that. If you didn't get that, if you had some Mac that, was incompatible for that, just go with whatever it suggests. Okay, we'll work on this in a minute. If you want to, if you ever for some reason need to use specific project JREs that are different from your standard setting, you could set it that way, right? But we just like to use one, if everybody's using JDK8, that just solves a lot of problems for me helping people code. The rest of it, leave as is. Just leave with the default settings and click finish. Boop. Okay, so now over here in our Project Explorer window, we have that. By the way, if you ever exit out accidentally, right, say, oh no, where'd my project panel go? You can go to Window, you can go to Show View, and you can go to Project Explorer, right? And you can make it appear. The other thing you can do is if you haven't set anything as different custom settings, you can just close out Eclipse and reboot it. If you're like, because sometimes things that happen is Windows can migrate from one corner to the other, right? And sometimes you're like, oh, what just happened? And if you can't figure out how to set things back to where they should be, you can just close out Eclipse, relaunch it, and it'll be back with the default settings. Okay? Okay. So let's do something in fall 2024. So, okay. By default, there is a package in there, even though you don't really see it. There's this SRC. SRC is for source. So that's where your source code is going to go. Okay. Now let's make a little application. So to make an application in a particular place, just highlight the folder where you want it to go. Okay. And then click on this, which is a green C, which is a green circle with a white C in it. And if you look real close, there's a little yellow plus sign in the corner. So plus new class, right? We're making a new class. So go ahead, click that, and it'll say, oh, okay, you want to make a new class. Well, let's give it a name. Let's call it vehicle. Okay, and we'll work with some of this later as the course goes on. We're not going to make any of these other checkboxes. We will in a minute for another one, but just type in vehicle as the name and do finish. Boom. And now we have this class vehicle. Okay, if you like, we can create some non-executable comments at the top with 2 forward slashes and say, this is a class for a vehicular object to track its speed and direction. Okay, so that's what we got here. We'll fill some of this out in a minute. Now we're going to go back to the default path. You can highlight that because we're going to use that, even though Java will tell you not to. Okay, we're going to make one more class. We're going to make an executable class called a main class. Oh, wrong button. Okay, so click on class again, and we're going to make a class called vehicle manager. Okay, and for that one, we're going to click on that. We're going to click on that stub that says public static void main string square brackets args. Okay, do that. Okay. And because it has a main method, this is the main class for our vehicular application. And where we launch the application, right? So anytime you're running a Java application, it launches from this method called main. The main method is always the starting point for a Java application. Okay, and it must have this particular format, right? You could have a main method with other characteristics, like instead of public, it could be private. Instead of static, it could be not static. And then it wouldn't work as the launching point for the program, right? So these are important magical incantations which enable our application to start. Okay. By the way, you'll notice both classes up here have a star. That means they haven't been saved since they were edited. So if you click Control S on a Windows machine, the star goes away. It saves it. Same thing. You click Control S on vehicle, the star goes away. They're current. Okay. Now, we've got these two things. If you have a Mac, or if you've done one of the later versions of Java that's not the JDK8, you're going to see some extra file in this folder, right? That's basically like a configuration type file. Does anybody have that? Anybody have like a more recent? You got it? No? Nobody has it? If you see that little file, just delete it, right? Because what it is, that's basically an extra layer of modularity checking. And that's one of the things I see with the people who have the newer versions of Java, is that it requires that by default. And again, I'm not saying it's not useful in an organizational setting. I'm saying that for IDS 201, where you're just learning, it's an extra layer of headache that it's forcing additional constraints on how you code, right? This is pretty easy. We can just work with what we have. Often you'll get updates that say, you should not use, use of the default package is discouraged, right? If you go to create a class here, just without doing one, you just leave it. Sometimes you'll see that thing. Yeah, there it is. The use of the default package is discouraged. Well, fuck you, Eclipse. We're doing it, right? Thanks for the warning, but, intro stuff. Okay. Everybody good with the vehicle? We got the, okay. So now we're going to do something real simple. We are going to create two vehicle objects, and we are going to separately change their values and check them. Okay. So for every vehicle, we're going to start off just giving it a speed attribute. Okay, so this is the vehicle's speed attribute. I guess we can say in miles per hour. Sure. And we're going to set it with a default value of 0. Okay, so we're going to assume that initially the vehicle is at rest. All right. And that'll do for now. Okay. The second thing, we're going to have to go to Vehicle Manager and create two new vehicle objects in our main class, in our main method. So the way we do that is we have what's called a constructor. We have a constructor. We have declaration and creation. All right. We'll get more formal about this next week. Declaration and creation of the vehicle objects. Okay. Declaration means telling the IDE what thing the reference is. Okay. And creation means making that object usable. Okay. So I'm going to do it all in one shot. We're going to have two vehicles. Vehicle V1 is a new vehicle, and vehicle V2 is a new vehicle. Okay. And if you've done it correctly, you'll see some little warnings here in the side. It'll say the value of the local variable V1 is not used. They're asking, hey, why haven't you done anything with this? Right. But that's not the same as an error. If you actually have an error like leaving off a semicolon, you'll see this red X in the margin. Okay, that'll indicate that there's something syntactically invalid in your code and you have to fix it. Okay, cool. All right, again, there's going to be a lot of stuff that we're going to have to come back to later. We'll talk about declaration and creation. Here we're doing what's called calling a constructor method. For now, we're just going to get some code that works. Okay, so push the I believe button and we'll go on. Okay, so I'm gonna put in a note. This creates two vehicle objects named V1 and V2. They are separate, right? They're stored at separate points in memory. They have their own independent existence. Okay. Now, suppose I want to set V1's speed to 10 and V2's speed to 20. Well, I can just do here V1. I don't know why. There we go. That took a minute. That was weird. V1 dot speed equals 10. V2 dot speed equals 20. Okay, so this is our basic dot notation. You're going to see it all semester. Basically, the dot notation means the speed attribute of V1, right? So V2 speed, V1 speed. Okay, we're just setting it to 10. If we want to reference those things, suppose we want to display the speed, okay? We could say, hey, what's V1 speed? Well, this is a print command. Oop. Make sure that doesn't happen for you. Okay. So system.out.println, right? Just this part here. That's the command telling Java to print out to what's called the console, a little text display at the bottom window when it appears. Print out whatever you put in that line, right? Whatever you put in the parentheses. And here, I'm combining some stuff. So this inside quotes, that's just a text string that's going to be printed as is. The plus means concatenation. It's going to follow it up with whatever follows. And here I'm following up with V1 speed attribute. So basically, we have this object V1. We've set its speed to 10. If I want to read what that object's speed attribute is, then that's what V1.speed is going to do, right? The machine's going to look it up and say, oh, it's 10, right? Likewise, I can do that again here with V2 speed and print out V2.speed. Okay? All right. So let's run this. And it should be very simple, right? It's just going to create the vehicles, display their speeds. Ta-da! And so if when you click run, that's what should happen. And hopefully that's good. Are people mostly successful with this? Is this, yeah.
That's the administrator. So just wondering.
Oh,
Yeah.
did you make some both main classes? You shouldn't be able to run, cancel. Yeah, let me see your vehicle class. Oh, save it. Oh. Yeah, okay. And save the other one. I'll try it. Yeah, sure. Yeah. Oh, capital. Has to start with the capital letter. There, right? I'll try again. You probably also can't put a space in. Has to be left together. Yeah. Yeah. As you will see over the course of the semester, Java is extremely picky. There's some coding where the computers kind of try to figure out what you mean and go with that. Like if you do a Google search and you type in something wrong, it'll figure it out. Java, no way, man, right? Java, you have to type in exactly what you mean. And so one of the strictures, number one, I'm just saying, just going forward, you gotta type in stuff exactly as I do. I know people make mistakes, you know, I make mistakes too, it's okay. But like if I do here, there's no space, you can't do a space, right? And for example, class names always have to start with a capital letter or a $sign. That's, or maybe an underscore, I forget exactly. But in this course, I always just start them with a capital letter because, you know, as I'm sure you're all thinking like, wow, this is a lot of complicated stuff. Believe me, I'm giving you the simplified version, okay? Because Java's complicated. Okay, so again, yeah, if there are any typos that you make, white space is one thing. Like generally you can put in a few empty spaces between anything and it won't matter. But for reference names, class names, yeah, it's going to matter for that, right? For example, if you separate V1 and V2, Java says, nope, can't do that. Okay. All right. So just saying Java's real picky. Okay. That's all. All right. So we've done this. We've got their speeds. How are you all? You guys all doing okay? Yeah. Okay. Okay. So what we've done is created some stuff. We've looked up some stuff. Now we're going to do one more thing. All right. This is about modularity and generic referencing. Okay. So I'm going to first of all, I'm going to make this int private. Okay. And private is going to throw off my other code off the rails, right? You're going to see that there's some errors in there. We'll talk about why. Okay. This attribute is private. Can't be accessed by outside classes like vehicle manager. Okay. Instead, we're going to include two methods for accelerate and decelerate. Okay, so I'm going to have one void accel, and I'm going to say speed plus equals 10. All right, so I'm going to say this increases the object's speed by 10. Okay, and decel, as you might guess, this increases the object speed or decreases the object speed by 10. Dun, dun, dun. Okay. And we're going to say speed minus equals 10. Okay. So now we have these two methods. These methods provide a mechanism. These are not, even specifically make them public, right? Public void public. These two methods are public and can be used by outside classes. Okay. Now, the point of this is I could include some validation here, right? So, for example, in most situations, it doesn't make sense to talk about a car having negative speed, a vehicle having negative speed, right? You might say it's going backwards, but if we're already including direction in some way, then speed has to be 0 and up, right? Yeah. Okay. Physics class is different, but you would never have your car speed register that you're going at a negative speed when you're driving backwards. So this way, if I didn't have this in my initial code for vehicle manager, I could have just said speed equals negative 10,000, right? And there's nothing in the code to prevent that from being a possibility. However, in this application, I can do that. I can put in some checks. So for example, I could say here, if speed is greater than or equal to 10, then do that, right? This prevents and prevents negative speed values. Okay, so this is an if, it's conditional. Basically, as long as speed is at least 10, then I'm comfortable deducting 10 from it, right? If speed is less than 10, then if I deduct 10, I become negative. I don't want that, right? Likewise, I might here say, include a validation. This prevents speeds above 100, right? Maybe this is a self-driving car and I'm never going to let it go above 100 miles per hour. Okay, so I could say here, if speed is less than or equal to 90, then I'm comfortable adding 10 onto the speed value because it won't be above 100. Okay. This is some advanced syntax that we'll get to in a few weeks, but I know you don't know it for now, but I'm trying to make something a little bit interesting and useful. So, okay. We cool? Is this good? All right, I'm going to split them up so you guys can see one screen while I'm doing the other. Okay. Now, in here, right, I can't directly set a speed, But if I want to set V1 speed, I could just call Excel twice. All right, set him once, right? And I could call V2's Excel method twice. And that gets me to the same destination. V1 speed is going to be 10, V2 speed is going to be 20, right? And if I try to do something like some bonehead thing like V1 decel, it's not going to let V1 speed be -10. It's just going to stop at 0, right? So I can run this one now and close out this window. Oh yeah. And in order to print it, I need a method to do that because I can't even directly access this. So I'll put in a get speed method. Okay. So 3 methods now. Okay, so I'm going to have one here called public int get speed. And that int, it's what's called a return type. That specifies that this particular method is going to send back a value. So when I call get speed, it's going to have to send a number back. Okay, and the number is just going to be return speed. Okay. This method has return type int, so it must return an int variable. An int variable is basically an integer between negative and plus 2 billion. Okay. And that's pretty much it. Okay. And I'll say it provides a way to read the object's speed attribute, even though speed is private. Remember, outside class can't look directly at the speed, can't read it because it's hidden, but because this method is public, any outside method can call that and read it, right? And this is a way of enforcing, hey, outside applications, you want to check in and see what speed this vehicle is going? Great, go ahead and peek, right? But you want to change it, you got to go through one of these 2 methods, because that way I can control, what's going on in the application. Okay. Cool. All right. So I'm going to replace this in Vehicle Manager. Instead of being speed, it's going to be get speed. Oh, I need that second parenthesis. And instead of speed below, it's going to be get speed. Okay. Why is this giving me a... Did I not save? I didn't save. Okay. Okay. So make sure everything's saved and you should be fine. And I can run this now and it's going to do the same thing. Remember, V1 decel, it's going to ignore that. The speed will be 0. V2 accelerates twice. Speed is going to be 20. Cool. All right. So we did some stuff. We created objects. We created a little working application. We got a little bit of insight into modularity. There's some good stuff to think about going into the weekend. Questions on any of this? Questions on Eclipse stuff? Bring them on up. We'll talk. Okay, this is all I got. I will post this code to Blackboard later, though. Okay, yeah.
Downloading.
Yeah, and if that doesn't work, like I said, just get a more current one. Because a more current JDK, right? So you can, if you go to Oracle, let me get here. Oracle Eclipse download for Mac. Right. So here we have I don't know, that's 2015. That's newer package. Okay. This one, the R, you can get that. Okay, so you're using R then. That's fine, but you're trying to load JDK8. Okay, yeah, like I said, that is the file you download and try to unpack and install. And if that doesn't work, again, just get a newer JDK. I think the current one that's not super current but good enough is 17. Okay. Yeah, sure. Pardon me. It's okay.
Is this the right program?
Yeah, that's
what's
Eclipse.
it- sorry.
You're good.
I don't know if this is like a Mac thing or not, but it wouldn't let me name my programs the same thing that you did.
Oh, let me see.
Like I wanted to like, forget how you did it, but like,
Let me see your project folder, actually. Can you
Yeah.
tilt that a little? Yeah, I won't be able to see what you're doing, but here, just open the folder you had. Sure, whatever you were coding in. Okay, well, here, try to make a new project then.
yeah. A new project and then, like Java project or whatever. I wasn't able, it wouldn't let me name it like,
Oh, do capitals.
or yeah, I tried.
IDS, you have to keep going though. Okay, it doesn't matter if it's capital. or not. IDS 201
It wouldn't let me do it.
space. Oh, that's the module. Yeah, I told you there's gonna be there's some module troubles. This is an annoying thing with the newer versions. Oh, here, so down below, see, down below at the bottom. That's where it is. I don't work, see where it says create module info, those two check boxes? Uncheck both of those. Now you're good. Okay,
Okay.
yep, Max,
Okay.
yep,
Thank you.
sure. What's happening?
So I'm the person, I downloaded, I extracted. all the
Yeah.
files, and so this is the application, right?
Yep.
Right here. When I click it, it gives me this.
Hmm, that's interesting. I would say, remove it and download it again. And then let me see the unzipping portion. Let me see in your downloads folder where, yeah. And show me, okay, so you have unzipped it. What's in there?
And this one?
Yeah, okay. Yeah, and run Eclipse and it does that horrible thing.
Yeah.
Huh. Well, I'm not sure. Maybe I would say just move it out of, is this a Mac? No, it's
No.
not. That is strange. Okay. Try saving it to a different folder, like on the, what could not open it? That's not.
So I forgot to mention, I have two accounts on here. This is my dad's account.
Oh, then
That's his
that's,
profile. So does that mean it's on his? user profile?
it could be. Yeah, I don't have this, the split account stuff, but yeah, one of yours, maybe it doesn't have permission to install things on yours.
Okay,
Yeah,
I'll check.
yeah, that's, it's almost certainly with that, right? If you can, just go up to like the root directory that's not associated with a particular person.
Mhm.
If you can do that
Okay,
and try to install it in a way that makes it available for all users.
okay.
Yeah, that seems like the fix that's. If not, come back Tuesday, we'll talk.
Okay.
Yeah.
All right, thank you.
Yep, sure. What's happening?
Executable partition, so I'm not sure I downloaded it.
Okay, did you unzip the file when you got it? Let me see it in your downloads. Oh, then that's what that would
That's
be.
what it is.
Yeah, well, it looks. Yeah, you
Oh,
gotta,
it's compressed.
yeah, actually, you did do it, so try opening that one and running Eclipse from that folder. Application. Strange. I mean, it should be that one, but that's not the one, that's weird, something's missing. Okay, yeah, try to unzip it again. It looks like something went wrong with the unzipping. So, up again. No, it's just keep going back up, yeah. All right, so right click on did you do the JDK?
Yeah.
Okay, yeah, so unzip that and install it. Open in. Yeah, did you? No, go back. You gotta unzip it. Yeah, no, we'll come back to it. Go ahead. Okay, so go back. Things aren't gonna work right if you don't, okay, so right click on it. Extract all. Yeah, and extract. Yeah. It's gonna turn wheels for a second. Okay, now you can run that. And just do the same thing with Eclipse, right? So do extract all and then run, yeah, do yes. And then do the run Eclipse thing and it should run fine.
Okay, thank you.
Yep, sure. Yep. What you got? Nick?
Alright, so I
Okay,
tried
okay.
downloading the clips and the GDK thing. with
Yeah.
those links. It didn't really work.
It doesn't work for you?
Yeah,
Okay.
but I just ended up going watching YouTube videos, so the guy
Yeah.
just ended up downloading it from the Eclipse page. So I was gonna
Okay.
ask if this is the correct version.
Yeah, that's cool.
Yeah, this
All right,
one's,
yeah, did you get JDK or are you using like 17 or something?
17. I think.
Yeah,
So it just came-
that's fine, it'll work, yeah. Just when you go to create a, same thing for you? Or- Okay, so here, let me show you guys both at one step. So when you go to create a class, just cancel, oh, create a Java project, good, okay, same place. So create a Java project, start with that. You'll see these boxes down here on module, just unclick both of those check boxes. And then you'll get by a lot of the headaches. So like I said, the later versions of JDK, they want you to have things, an extra layer of modularity, which for what we're doing is not necessary. It's just a headache. Yeah,
I got it, but like, I got to that page, but
Okay.
somehow I closed it and I never got back
Okay.
to it again.
so you have Eclipse open then, or no?
I got the installer, and I don't know. what it
Okay,
is.
so close that out, because I don't know. But let's just go to, if that says, okay, that says did you unzip it? Okay, so go back up then, go back to the downloads wherever it's stored. All right,
I downloaded all of them. Check which one's
Okay.
working.
yeah, whichever one, yeah, Eclipse install JRE Mac, that's probably it. But you seem to have the application there, so try the one just above it, see if you have, yeah, see if you can just run that.
That one doesn't open. I tried it.
Okay, all right, so unpack the other one, the DMG, right down below it,
This one?
yeah. Okay, sure, try and, yeah, it must be, okay. Like I said, I don't spend a lot of time around Macs.
No, I get it.
Okay, I mean, let me see. Okay, Eclipse ID for Java develop, yeah, I'm gonna hope. Projects you want to provision. Is this the enterprise edition? This seems weird.
I'm pretty sure redownloading it from the same page. Right?
Yeah,
Same page.
The Eclipse download.
Yeah.
okay, let's try this. See, how do you extract? How do you extract on a Mac? This is gonna be a packed one.
Yeah, you want me to open this one or?
Yeah, you see if you can unpack it first, because you know,
I guess we an option to compress. That's it.
oh, it is, so it's not compressed. Okay, that's good. Well, okay, we'll just run it then. Double click and let's see what happens. Yeah, but
Yeah, it's just the same thing.
okay, try it. Yes. Weird. Okay, I don't know. Yeah, we'll try to figure that out on Tuesday. I'll send me an email about it. I'll see if I can send you some links, but yeah, I have to look into it.
No problem, thank you.
Yep. Gotta clear out of here. Hey, what's happening?
I was just really confused during the class. I
Okay.
don't know, am I in the right place? Like,
Yeah, that's Eclipse. Oh, you want to get rid of that module file though, right? Module info dot, just get rid of that. Yeah, exit. Yes, don't save. Okay, now open up your source folder there. Okay, nothing and nothing in the other one. Oh, there it is. Yeah, get rid of that module info. See, that was the thing. If you get the later versions of Java, it always wants to include that module stuff. And when you create a project, there's a couple check boxes down at the bottom. Just leave those unchecked and it won't demand that you do that. Yeah, let me show you. Just create a new project.